Hey there, Soda Speakers. Nico Perino here. Before we begin today's show, I wanted to ask a favor of you all. Every other week for 2.5 years now, we've given you what I hope are interesting conversations and stories about the world of free expression. We've explored how free speech intersects with comedy, theater, neuroscience, social media, battle rap, artificial intelligence, beer, turkey, the country, not the food, sex, campus speech codes, and so much more. If you enjoy what we do, I hope you will consider making a tax-deductible donation to the Foundation for Individual Rights in Education before the end of this year. FIRE is the organization that makes this podcast possible, and all gifts of any size help. To make your donation, please visit thefire.org/donate. Again, that's thefire.org/donate. Donating is simple, it's easy, it's tax-deductible, and it's much appreciated. Now, on to today's show.
Freedom of speech.
Fundamental rights.
Freedom of conscience.
Academic freedom.
Freedom of press.
And the right to listen.
You're listening to So to Speak, the free speech podcast, brought to you by FIRE, the Foundation for Individual Rights in Education.
Welcome back to So to Speak, the free speech podcast, where every other week we take an uncensored look at the world of free expression through personal stories and candid conversations. I'm your host, Nico Perino. Back in October, we spoke with the decision strategist and poker guru Annie Duke. We talked with her about her book called Thinking in Bets, Making Smarter Decisions When You Don't Have All the Facts. Now, in preparation for that conversation, I, of course, read her book, and I stumbled across a reference to another book that she said argues that every fact we've ever known has been subject to revision or reversal. Now, that struck me as a bold claim when I read it. We all know the world changes, but really, every fact has been subject to revision or reversal? If true, I thought, this could have significant implications for those of us who care about free speech. After all, if facts about our world are constantly shifting in this way, wouldn't free speech, the right to openly question the world and all we believe about it, become even more critical? The book Duke referenced was published in 2012 and is titled The Half-Life of Facts: Why Everything We Know Has an Expiration Date. Now, it turns out the book's author, Samuel Arbesman, his position isn't as strong as Duke let on, but still, there's a grain of truth to it, he says, and that's what Samuel, or Sam, and I discuss on today's show. Sam is a complexity scientist whose work focuses on the nature of scientific and technological change, and he's currently a scientist in residence at Lux Capital, a venture capital firm that invests in emerging science and technology. We discuss his book on today's show and how our world and the facts about it constantly change, and what, if anything, this means for us free speech advocates. We explore social media, collaborative networks, non-compete agreements, zombie movies, undiscovered public knowledge, and what public policy implications might emanate from an understanding of how knowledge grows, changes, and deteriorates. Enjoy. All right, well, Sam, thanks for coming on the show.
It's my pleasure. Great to be on.
I was reading your biography, and it says you are a complexity scientist. What does that mean?
So complexity science is basically the study of complex systems, which doesn't actually tell you that much unless we can define what complex systems are. And complex systems are basically large systems that have a huge number of interacting parts that all, and this can be whether in biology, it can be like the parts of a cell, it can be an entire organism, it can be an entire ecosystem, it can be within technology, so lots of technological systems interacting like the internet, it can be within social systems like societies or cities, things like that. But the idea is that no matter what the complex system, it turns out there are underlying similarities to the structure of the network of interactions, the underlying behavior, potentially even sometimes the emergent behavior that arises. And that's actually one of the hallmarks of complex systems, is this idea that due to the interactions of these large systems, of the parts of the large systems, you might get behavior that you might not necessarily be able to predict simply by just looking at the individual interactions. So like, for example, the behavior of a beehive might be hard to understand just by looking at an individual bee, or the flocking behavior of birds might be hard to understand just by simply looking at the behavior of an individual bird. And so there's kind of this emergent behavior that arises, and it can be studied in a computational and quantitative way. And that's sort of what complexity science is very broadly.
And you argue in your book, The Half-Life of Facts, that knowledge creation and deterioration can kind of be analyzed in this way as well, right?
Yeah. So the idea is that that like knowledge creation, kind of the way we think about facts and information, if you look at an individual fact or a bit of information, you don't necessarily gain that much. But when you take a step back and look at the overall production and generation of information and knowledge, and how errors get rooted out and things like that, suddenly there are actually regularities. And so, and the book's title comes from this sort of analogy of the half-life from radioactive decay, that when you have a radioactive material, if you have a single atom of uranium, for example, it might decay in the next fraction of a second. It might decay maybe in like millions and millions of years. You really can't predict it. But if you get a whole bunch of uranium atoms together, if you get an entire chunk of uranium, for example, suddenly the radioactive decay goes from being entirely unpredictable to actually quite regular. You can actually graph out this half-life of decay. And the same kind of thing, at least on some level, is true with how we think about knowledge. That when you look at knowledge as a whole, suddenly there are actually regularities to how we think about how knowledge grows, how it spreads from person to person, how it gets rooted, how error gets rooted out, how it gets overturned, things like that. And
who started, I believe you call it, or there's a name for this sort of study, it's like scientometrics, right?
Yeah. So scientometrics is basically the science of science, kind of like quantifying how science changes over time. And some people also call it, like, there's, I think, meta-knowledge, or people say science of science as well. But I mean, people have been thinking about this for a while. I would say at least one of the founders is this historian of science and physicist, Derek DeSola Price, who actually compiled a huge number of quantitative ways of understanding scientific change. He looked at the growth in scientific journals, the growth and change in publication, and the story goes that one of the ways he initially thought about this was he had all the actual print issues of a scientific journal in his home, I guess, like in piles against like one of the walls of his apartment, and he noticed that the heights of these piles actually conformed to a nice mathematical curve, and then it began his kind of thinking about this sort of thing.
So that's the growth of knowledge, and the growth of knowledge follows a predictable curve, you argue, but it's different for each field of knowledge. For example, the curve in studying opera might look different than the curve in, say, studying biology or a disease, for example, right?
Yeah, and I think that's kind of the exciting thing, is that different fields of knowledge, because of the differences in how those domains work, and kind of the sort of fundamental properties of these fields, they're going to actually have some differences, and which means you can kind of begin to think about what you should expect when you deal with different fields. Like, for example, in medicine, there's a lot of change, especially in terms of what is kind of current standards of practice versus things that are obsolete or no longer true. And so in physician, or I guess medical students, when they're being trained to be physicians, are told explicitly in medical school that like a good fraction of what you learn is going to be overturned within a few years of graduation. And so you really need to be thinking very consciously about the idea of this concept of like the half-life facts, and the fact that knowledge is going to be changing. And you really need to very explicitly try to update your information, because lives are on the line. So it's really important.
And you argue that almost every fact that we've ever known has been subject to revision or reversal, correct? For the most part.
I wouldn't quite say it that strongly, but I would definitely say that there are many instances where things that we thought were true have been overturned. So like, for example, so my grandfather, when he was in dental school in the I guess in the 30s, I believe, he actually learned the wrong number of human chromosomes. He actually learned that there were 48 human chromosomes instead of 46, because it turns out when there weren't as good imaging techniques, someone had measured and counted, and I guess in this case, miscounted. And this bit of information propagated, and it actually made it into the textbooks and was propagated for, I guess, several decades, until in the mid-1950s, there was a better imaging technique developed, and people decided to recount and realize that there were actually two fewer than people thought. At the same time, though, I think when you talk about how knowledge gets overturned, it's not that everything we thought was true is now wrong, and so we're kind of just flipping between states of certainty, and then suddenly we're ignorant again, and we're worried about it. There's this constant sort of asymptotic approach to the truth, and so there's this great quote from Isaac Asimov, where he's corresponding with someone about like whether or not the Earth is flat or not, and he's saying that he says. When people thought the Earth was flat, they were wrong. When people thought the Earth was spherical, they were wrong, because it turns out it's actually this like oblate spheroid. But and Asimov continues saying, but if you think that thinking the Earth is spherical is just as wrong as thinking the Earth is flat, then your view is wronger than both of them put together. And so there's this idea that we are getting closer and closer to the truth. And so things might be overturned, but it's in the service of actually getting closer and closer to some sort of better understanding of the world around us. And so, and part of that, and you see like when Newtonian mechanics was overturned by Einsteinian physics, it wasn't that suddenly Newtonian mechanics is thrown out. I mean, it's still actually quite useful for a lot of things like building bridges and building buildings, because these buildings are not being built at large fractions of the speed of light, and so those kind of the Einsteinian checks on them are not necessarily that relevant. But we are kind of getting closer and closer to a better understanding. So I would say that's probably the caveat to better understand how we think about overturning knowledge.
A greater conception of the truth, in other words.
Right. Mm-hmm.
So why is this important? I have some theories as to why this is important from the perspective of a free speech activist. But why did you want to write this book? Why did you think writing about the half-life of facts, or how we gain knowledge and how it's subject to revision or reversal, was important?
So one of the reasons it's important is because at one level, every one of us intuitively knows to a certain degree that things we might have learned when we were young, or things that were in our textbooks when we were students, are no longer true. That things have actually been overturned. But at the same time, though, it's not just this pattern of complete flux and just kind of constant change where, because I read that that food X is unhealthy, and now I read that it actually is healthy, therefore I can't know anything. There are actually rules and regularities beneath all this flux to how knowledge actually changes. And so I wanted to really try to understand this. And I think the other thing I was also very interested in is to get people to realize that, and when people think about science, they think of it in terms of this body of knowledge or body of facts. And science really isn't that. It's really it's a means of querying the world around us in order to understand it better. And I think if we go if we understand science in terms of that, then we're going to be a lot more positively predisposed to thinking about how knowledge is changing over time. And I also wrote this because I wanted people to better understand the scientific process of how people think about science. And one of the reasons when you think about science, there's often there's the core of science of a body of knowledge that makes sense. The textbook that maybe is not changing quite as much and really is reasonably well known. But then there's the frontier, where there's a lot of flux. There's lots of things changing, and this is the things we read about in the newspapers, in the science section, where this thing we thought was true is now wrong, or this bit of nutrition information has now been overturned, and that's where we know the least. But in truth, that's where the most exciting things are happening. This is the reason scientists work at the frontier, is because they really want to be actually overturning and better understanding the world around them. And so we need to really make an effort to better understand how knowledge grows and changes, and in order to actually kind of embrace this idea of changing knowledge and science as a means of inquiry as opposed to just body of knowledge. And so there, a professor of mine in graduate school, he told me this story of this is already after I had graduated. He told me that one day I think it was on a Tuesday, he came in and taught a course on some specific topic, and the next day he actually read a paper that invalidated the lecture from the day before. So then he came in on Thursday and then said to his students, "Remember what I told you on Tuesday? It's all wrong. And if that bothers you, you need to get out of science." And so I think there's almost this sense of delight and wonder of yeah, these things are changing, but this is when that's changing, then science is being done right. We're actually learning more and more about the world. So really I wrote this to get people to better understand the scientific process, engage with science as sort of this means of inquiry, and really delight in the fact of that we're constantly learning more and more about the world.
Yeah, one of the big questions I have after reading your book is more or less how we better embrace this change in knowledge. and whether there's certain possible public policy implications from your thesis about knowledge. As we've talked about, you posit that knowledge creation and deterioration can more or less be predicted. But does that theory hold regardless of environment? Like, for example, is it the same in China as it might be in the United States? I was told, for example, that a lot of the basic code that the U.S. web developers use as building blocks for bigger projects can be retrieved by the internet searches. It makes their jobs a lot easier. But in China, that code is often hidden in websites that are censored. So the coders have to develop that code from scratch, making the knowledge production process, one might say, a little bit more difficult and perhaps slower. So I'm wondering what you think of the public policy implications of this, and whether the environment, if it's held constant, has any sort of effect on it.
Yeah, so I guess I'm not sure I've thought about specific policy implications as much, but I would say kind of building on what I was saying before, like the hallmarks of science, like it's not this body of knowledge. It's kind of a set of ways of querying the world, and I think one of the ways is that like science is cumulative. Like you build on what came before you. Like you cite papers. You try to replicate studies. You look at data that people have done, maybe analyze it differently. And I think when innovation is occurring behind closed doors, or it's kind of like the output or the product of science is not as public, then people are not going to be able to participate as much in this process, in kind of like science when done right, like this kind of this open means of querying the world where you test things, you try things out, it's cumulative, you build on what has come before you. And I think, you really want to make sure that that in order to kind of make sure that science is as cumulative as possible, you want to provide kind of the right kind of incentives for people to get credit for their work, kind of recognize priority, be part of a community, share information, and really kind of make sure that all in service of making sure that our body of knowledge isn't constantly improving and being shared and being as useful as possible. So I would say when there are policies that allow this sort of open exchange of information and testing, like those are the kind of things we want. And so, I would say those are the kind of like policies that we want in place.
Yeah, you sort of want an environment that encourages open inquiry. And that's my, main interest in this topic, because we often argue in free speech or academic freedom or open inquiry circles that one of the reasons you want that is not just because it helps the democratic process, for example, or that it is a boon to individual liberty and autonomy, but also it helps produce new knowledge, and as a result gives us all the cool tech that we like. It helps us live longer. It makes our lives all around more fulfilling when we learn more about our environment. But in reading your book, it seemed as though there was almost sort of a determinist outlook at how knowledge marches forward. And I was just curious whether it marches forward regardless of our environment, and whether science and knowledge doesn't have all that much to say about open inquiry, and people will find their way to new knowledge regardless of their circumstances.
I would say I don't think my argument is kind of like that deterministic. I think it's predicated on certain forces and like the properties of the scientific inquiry actually like being present. So like, for example, if you can't publish your work or cite things in certain ways, then not only would science, from my perspective, not necessarily proceed as quickly, but in many ways you can't actually even measure some of these kinds of things, because a lot of the metrics that I'm talking about are based on understanding citation and understanding how people kind of exchange information. So I do think it's not as these things are not like the gravitational force where it's just like, oh, you set things in motion and then suddenly everything is going to be happening. Like these are not laws of nature. These are dependent on sort of a good scientific climate. And related to this, I mean, you can see that, and going back to like public policy things you were talking about, the United States government has put in place like certain things about like making sure that people are sharing information within a certain amount of time after publication of their research. I I don't remember the exact details, and I'm not, and it always kind of depends on how people like and the details clearly matter to make sure that people can not only just see the raw data or see kind of some sort of like the scientific models that were being used, but really being able to kind of reproduce things and actually test things. Because I think part of making sure that science marches forward is really having this sort of like self-correcting feature within science, and part of that self-correcting feature is weeding out things that are not actually correct, that are flawed or don't work in the way people expect, or have a huge number of caveats in terms of their applicability. So I think really making sure that you kind of have this openness and this shareability is very important. And related to that, though, I mean, people, and there are many people who are thinking about this very broadly. So, for example, and like one of the classic things that people always talk about is, we're in the 21st century. We have these amazing technological tools, and yet, at least when it comes to like the dissemination of our research, in many ways we are stuck in the mid 17th century. So like 1665 is the publication of, it was like the first two scientific journals, I think, were 1665, and even though we've in many ways, science has progressed quite a ways from the 1660s. We still use scientific journals and scientific articles as the means of disseminating our research, even though there's many different ways to rethink this kind of thing. And there are people rethinking how and what scientific journals should look like, how we should be disseminating this. Also recognizing that now a huge amount of scientific research is not just traditionally kind of like bench research. It's also incredibly computational. And so really being able to share the computational construct that you have for however you collected the data, examined it, ran some simulations, whatever it is, being able to put it in some sort of format or package that people can then easily run on their own machines, I think is actually really, really important. And so people are trying to think more broadly about how to have reproducibility of computational research as well, as increasingly all of science becomes computational. So I think there are a lot of people thinking about this kind of thing. But yeah, I think we still have a ways to go.
Yeah, I'd just love to see, for example, what the knowledge curves look like in all these various domains. For example, in North Korea, if we could study in North Korea, and is the curve as pronounced as it is in, for example, a lot of the open global Western and Eastern countries? I mean, knowledge in many ways is a global enterprise at this point with our increased communications technologies. And North Korea is really the only country, the hermit country, where you might be able to test an alternative model. But
yeah, and to be honest, I'm not even sure, like looking at any like curves of like, the growth of scientific research within North Korea, I'm not even sure that would even make like it would be meaningful if it would just be, and maybe there are papers there. I to be honest, like really have no idea. But yeah, I don't know if those papers are good, if they're just citing each other, and suddenly it's this kind of like a weird little environment of this kind of strange like North Korean science. I have no idea what's going on there, and I don't really even know if it's like science as the rest of the world might understand it. Yeah, so I really think the exciting thing about science is that it really is, for the most part, transnational, international, and I was not. I was not doing research during the Cold War, but my sense is, at least from what I've read, is that that was one of the few ways in which the Soviet Union and the United States worked together, was actually through the scientific communities of those two countries, is that they actually were trying to share information as best they could. And of course, there were many times they were not. But I think science, when done right, really has this power to kind of just like make information transfer as open as possible, in the service of learning as much about the world as we can.
Can we predict when challenges to new knowledge might happen? And when I say challenges, I mean like outside the scientific community, namely from outside actors. Sometimes it might be governments, other times it might be interest groups. I'm thinking here about some of the climate change research that's come out in recent years, maybe the stem cell battles of the 90s and 2000s, the Copernican revolution. It seems as though the challenges come when they implicate some sort of culture war battle. And you also talk about how knowledge, it's harder to discover after you've taken care of these easier to discover problems. I don't know if I'm phrasing that correctly, but as things become more complex, I'm thinking that they also might become more abstract and confusing to a lay audience, and then also less likely to be challenged, either through censorship or through, regulation.
So maybe I'm not sure I understand the question. So the idea is like when do people kind of rethink certain scientific dogmas? Certainly, you want to have a healthy amount of skepticism is, I think, reasonable and good. I think though, being a contrarian for contrarianism's sake, or just kind of like skeptic because sort of like a knee-jerk skeptic, I think that's not necessarily productive. So are you asking more about whether when sometimes there's some sort of cultural movement to begin questioning certain areas of science, or when it's when within science there's certain time certain scientists saying let's actually re-examine certain scientific things that we think are true that maybe are not, and because we have certain weird exceptions or bits of data that don't make sense.
Well, I guess this is kind of piggybacking on my earlier question about the public policy implications, just whether it's even possible to predict when a piece of knowledge will be challenged, not for its veracity, but more or less for some of its downstream implications. I'm thinking about stem cell research here. I'm thinking about the argument that the sun is the center of our universe. Even maybe you can apply this sort of line of thinking to the CRISPR dialogues that we're having right now, and how concerns about what CRISPR might result in might impede what would otherwise be just the general march in the direction of implementing some of those technologies.
Okay. Yeah. And I guess I'm going to speculate here, but perhaps one of them is just simply when there's a greater distance between sort of the scientific community and the general population. And so there's less of an understanding, or maybe there's a breakdown in the ability to explain certain scientific ideas to a general audience.
Yeah.
But I'm not entirely certain that those are correlated with the increasing complexity of a specific subject. Because I think actually, I do believe that when engagement with the public is done right, even pretty complex and esoteric ideas are able to be explained to a general audience. And so perhaps maybe it's a less of a willingness to try to explain these kinds of things. Or maybe just a simple inability to do that. I don't know. Again, this is very speculative, but I wonder if it's kind of some sort of when there's an increasing gap, then into that gap comes a certain amount of skepticism or concern, even though it really doesn't make sense within kind of the scientific community. It's because there's this gap in language or in discussion. But I'm not sure.
Yeah, how important then is physical space, and perhaps something as basic as the number of people in a population in knowledge generation? I know you can say you can predict more or less how innovative a community is by its population, but there has to be more than that, if I'm not mistaken. For example, you don't get anywhere near the innovation of, say, Silicon Valley in a place like Sao Paulo, Brazil, where you have 12 million people, despite the larger population. And I've always been curious why Paris, for example, in the 19th century, and Florence in the 15th and 16th centuries produced so much more knowledge than some of the larger population centers elsewhere in the world. So what does population and physical space have to say here?
Yeah, so I think population, at a very rough level, a population is a very good sort of first order approximation, or even zeroth order approximation. It's a rough proxy for people being able to interact with each other and kind of having this sort of combinatorial interaction of ideas. And so people and one of the things I discuss in my book is that and Geoffrey West, the physicist, he's actually explored this in far greater detail, and he and his collaborators, some of the work that I cite, is this idea that if you look at the population of a city, you can actually look at how, as the sizes of cities scales, the sort of the productive output also scales. In this case, it scales super linearly. The idea would be that if you double the population size of a city, you actually more than double the productive output, like the number of patents or whatever it is. And the idea behind this is so there's this nice little curve, but of course the curve, when you plot a whole bunch of cities on the curve, it's noisy. They don't fit exactly. There's going to be a certain amount of noise. And then within that, there are certain cities like San Jose or kind of the San Francisco metro that overperform on that curve. And there are ones that underperform. And so I think, yeah, right. There's kind of this overall very rough draft of population matters. But then you can say, okay, then what are the details? How do we actually better understand why certain cities, certain regions are more effective than others at generating ideas or producing knowledge. And then there are a number of studies that people have looked at that are kind of more fine-grained. And I think that actually also shows that kind of on a finer grained nature, that distance and location also matters. So there was a paper that came out, I don't know, like 10, 15 years ago or so that looked at collaboration within actually, I mean, like down to like the level of like within a building. I think it was like looking at like within like biomedical research, and it was looking at collaboration patterns within at a university. And then they measured like the distance between these collaborators. And I think, if I recall correctly, looked at the number of citations that their research received, kind of as a rough proxy for how impactful that research is. The idea is that if more scientists are citing your research, then it is more important in some sort of very general way. And the idea was that they found that actually that the distance really mattered, that kind of the closer you were, the more highly cited. The closer the collaborators were, the more highly cited their research was. And so this idea that if you are closer, it's kind of like the sort of like water cooler effect that people always like talk about. That like if you have the ability to really interact, then you're just exchanging ideas, and there's kind of something in the air that where people can really kind of piggyback on various things, and there is a sort of combinatorial effect. In truth, I don't really know if people fully understand in some sort of generic kind of like mathematical way why Paris in the 19th century or like the golden age of Greece or ancient Greece or whatever, like why these things were so, or like Edinburgh in I guess like the 18th century or whenever it was like so impactful, kind of like out of line of like its population size or whatever. And I think then you actually really need to dig into the history and look at the details. And I think ideally from those details, you can maybe then try to create a more general theory and of understanding of like how population matters, how distance matters, how certain types of ideas and certain types of maybe the size of a university or the ratio of people at a university versus the overall size of the population of within that metropolitan area, how those things matter. Again, I don't know which of those are correct, but I think you need a combination of sort of these generic theories as well as looking at the historical details.
Yeah, it's just another sort of interesting point for me when you're looking at possible public policy implications for people who want to supercharge the knowledge generation process, or even, as a manager at an organization myself, how I can help my department become more creative. Maybe working from home or having multiple employees work from home isn't the greatest idea if sort of proximity is a generator of creativity and knowledge. I don't know. It's sort of an interesting thing to explore.
At the same time, though, I would just be mindful of the fact that some of these kinds of like certain effect sizes might be small.
Mm-hmm.
So it's the kind of thing where if you're able to do things pretty well, and there's a huge amount of cost to like reorganizing your entire organization or a city, like these kinds of there are trade-offs to just be kind of aware of. And there's also like a lot of like path dependence. So like there's a huge number of reasons why Silicon Valley is Silicon Valley, and many of those things are not repeatable in terms of like why a certain group of people moved from the East Coast to the West Coast, started their company, and then people fled that company and went to other things. And then there's like defense contracts and like all these kinds of things really led to why Silicon Valley is Silicon Valley. And some of those kinds of things are very difficult to really repeat. And so, then again, there are other things that probably actually do have greater policy implications. So people have actually studied whether or not the non-enforcement of non-competes is actually a really important factor for innovation. So the idea is that like having a non-compete, like when you move from one company to another, like you can't compete, you can't compete with your previous employer for a certain number of years or whatever it is. California does not allow enforcement of these non-competes, but other states do. And so the question is maybe this non-enforcement of non-competes actually is important for innovation. And I believe there were some economists that used this great natural experiment. And I forget the exact details, but I think it might have been in the 1980s. Michigan, I think, went from not enforcing non-competes to enforcing non-competes. And there was I forget which direction it was. But from that, you were able to note it. I think it was going from non-enforcement to enforcement. And they noticed that right around the time the enforcement happened, there was actually this like flight of innovative individuals from the state. And so there are certain policy things that can be done that are fairly easy to do. But I think other things like the kind of path dependence of history, it's very hard to replicate.
Well, it's interesting when you talk about non-competes. You can kind of see the same sort of innovation and creativity spawned around a more liberal fair use doctrine. For example, if you don't have to worry so much about someone coming after you for copyright infringement when you do some artistic adjustments to say a zombie movie or to a song, you get more people playing around and having fun with various versions of a song or a movie. And some of that has generated new ideas. I think there was actually, I forget what zombie movie it was, but the zombie genre more or less arose out of one of those early zombie movies failing to put a copyright notice on the movie, which allowed, and I'm going to go back and look at what movie it was so that I can put it here in the show notes. But they failed to put a copyright notice on it, and as a result, a lot of people used its more or less its intellectual property in any other context to spawn the zombie movie genre. So it's interesting when you allow that sort of creativity to spawn around and you don't build large walls around any individual enterprise, what can happen as a result. I wanted to ask you about citations and journal articles, because one of the big data points that you use when you're analyzing, not just you, but anyone involved in sort of examining this space, one of the data points you use are these journal articles and citations for them. But you say in your book that something like only 20% of journal articles cited were actually read by the authors, which leads me to believe that the citation of journal articles really doesn't have much to say about the veracity of what's actually found in those articles, just perhaps that some influential previous scholar had read it, cited it, and then someone else thought it was probably a good idea to cite it in their work as well.
Yeah, so I don't remember the exact details of like how people determined that I think only 20% were actually cited. It might have actually been through maybe like errors in citation where like there were typos and things. I forget exactly the detail, but certainly citations are a proxy for a whole bunch of different things. And you might cite a paper if it's influential, if it kind of is related to what you're doing. You might cite a paper only to try to actually refute it or to disagree with it. So it's certainly a very rough proxy. And so certainly, and I would say a much better gold standard for in terms of thinking about the half-life of knowledge over time would be something like actually surveying experts in a field and saying, okay, which of these papers are still true, which ones have been overturned or rendered obsolete. And so, and there are people who have actually done that kind of thing. So I think those are much better means of understanding how knowledge is thought about. And because at the same time, though, there are certain things that are incredibly foundational for science. And so, for example, like Isaac Newton's Principia. I imagine that is not being cited with nearly the frequency that many people might expect, given its kind of foundational status within physics. At the same time, though, that's not surprising. Like there's been a lot of things, and like since then, and I'm pretty sure it was written in Latin, and people aren't reading that. So I think there are different ways of kind of getting like understanding scientific change and kind of measuring certain scientific things. And I think people are getting better at finding a richer set of data of like how we think about this kind of thing. But certainly, and you can also see that as citations matter more for things like tenure decisions, then that skews the incentives for how people think about getting citations. And so not only do you have issues, but it's like authorship, where there are many many situations where one of the authors on a paper really hasn't contributed that much, but they're still on the paper for like kind of like cultural or sociological reasons, or kind of just like political reasons. In the same way, like citations are done for lots of different ways, for lots of different reasons. And I think we just need to be kind of, when we look at authorship order, which actually that varies from, like, in terms of the way people do authorship order, that varies from domain to domain. Citation, certain types of journals allow more citation. There's like space constraints, and if there's fewer space constraints, that might actually change how you cite things. So I think you just need
in your book, you talk about how like the more successful a scholar they are, the more likely that their name is listed later in the authorship.
Right, but that also, and yeah, so I would say, well, it's more that, and if you are kind of like the head of a lab, at least in like kind of like biological sciences, then you're sort of like the last author. So like the first author and the last author are often kind of like the most important. And then it kind of just like goes in from there to like the kind of very middle one, which is kind of least important. But I think in economics, there's many cases where it's simply just alphabetical order. And so if you were coming from a field that was not familiar with that and you looked at an economics paper, you might have a very different sense of who's important and who's not. And so I think recognizing the differences as well as like the limitations on how people think about these kinds of things, both citation, authorship order, all the other kind of factors, is really important. And people are trying to address some of these kinds of things. So I think now that there are a number of journals where when you have when you publish your paper, you also need to include what sort of tasks and what parts of the paper each author was responsible for, to kind of really make sure that the readers have a sense of who contributed what and kind of who was involved in what sort of thing and what went into like the actual output of the paper. So I think there are some good changes that are happening, which is exciting to see.
Going back to what I was telling you before about the zombie movies, I just pulled it up on my browser here, and the movie is The Night of the Living Dead, which was originally called Night of the Flesh Eaters. But then when they were going to change it to the more popular title that we know of today, Night of the Living Dead, they changed the title card and forgot to put the copyright notice on that card.
Oh, interesting.
Yeah, and and I'm reading an article about it today. They say that though it would not be a large issue today, in 1968, that meant the movie was not protected by copyright and instead was placed immediately into the public domain. And as a result, people were creating unofficial sequels to it that spawned more or less the zombie genre that we know today. Previous to that, it was more zombies were more thought of to be like voodoo zombies, people who had spells cast on them rather than sort of disease-ridden zombies. Just an interesting sort of quirk of how
that's fascinating. Well, and this also reminds me of like when you look at like the space of things that are in public domain, like in many cases it's not always easy to actually know if something is in the public domain or not, and that's a problem, because if you want to build on knowledge and information or just like creative outputs and products, you can't, because if there's a concern that it might be in the public domain, it might not be, then you and I imagine in many cases people just kind of err on the side of I won't deal with that, and we'll just try to choose something else or just not even make something. And you would love to make it easier so people can actually build on it, and you still want people to get credit and be able to kind of be like remunerated for their work. But at the same time, though, you still, the whole point of having copyright is to kind of encourage people to do things, but at the same time, making sure that it's time limited to also then allow it to enter the public domain and be sort of this body of cultural knowledge that people can build on.
Didn't early coders and web developers sort of implicitly or perhaps even explicitly understand this when they decided that they were going to, one of their ethos was going to be this open source framework where someone creates code, they were just going to kind of put it on the internet for other people to build off of?
There was certainly some groups of programmers were into this kind of thing. And certainly one of the major innovations of Microsoft was actually recognizing that software has value and therefore they should be paid for it. But at the same time, though, then there was kind of this other group saying that there's this open source movement and we want to kind of they create this sort of like legal structure to ensure that these things are not copyrighted or kind of or they have sort of like limited rights, and to kind of allow people to share things and sometimes actually force other people who use them to actually make sure that the things based on it are in turn also shareable. And so there's lots of different paths. For the way I view it is, you really want to make sure that there are as many kind of paths as possible, because you want people to kind of have options. And certainly open source has been enormously beneficial. And in many ways, science is kind of like the sort of apotheosis of this kind of open source idea, where it's all about, and because so much of it occurs in like the university setting, people are not getting paid for their research papers. In many cases, you often especially papers that are kind of publicly available. Sometimes university or kind of researcher actually has to pay to kind of get the paper published, even after it's after it's being peer reviewed. But the idea is that because the incentives, like the university and academic incentives, are for credit and kind of priority, are separate from ownership and copyright. It ensures that scientific information and scientific knowledge is going to be kind of as hopefully widely disseminated as possible. Now, of course, there's the whole scientific publishing industry, which has made a lot of this a lot more difficult because there are many, many things that are behind paywalls. And there are many people who have great concerns about this because these things are behind paywalls, even though a lot of it is government funded. And so therefore the idea is like, if it's government funded, I paid for it with my own taxpayer money, I should have access to research about some genetic disorder that runs in my family or whatever it is. Like this should be a public good. And so there are many people who are trying to kind of make sure that this information is publicly available and kind of more open access.
In your book, you talk about social networks a bit, and I'm interested in exploring social networks and how they help spread knowledge. Obviously, the more open channels of communication, the more easily or the easier it is for knowledge to be disseminated. But you also talk about how, the more open the channels of communication, the easier it is for like falsity to be spread as well. And your book in some ways was prescient here when we talk about fake news today, for example. As Benjamin Franklin put it, a lie gets halfway around the world before truth has a chance to put its pants on. And I think about this in the free speech context as well, that there's that first mover advantage. And the Voltaire quote, or the alleged Voltaire quote, I might disapprove of what you say, but I'll defend to the death your right to say it, isn't actually a Voltaire quote. It's actually a quote from one of his biographers, Evelyn Beatrice Hall, but it was put out there. It was catchy. People liked it. And so now it's ascribed to Voltaire and people don't even think twice about it. So I wanted to hear a little bit about how your thinking of social networks has developed in this age of when we're talking about fake news and how social media might amplify it.
Yeah, and so and certainly like an error it's very hard to root out within sort of a body of knowledge, and it can spread easily. Like you can see like retracted papers, they're still they can still be referenced like years after they've been retracted, and we might need like better mechanisms for like error correcting within science. And I think part of that is also just the idea that that even though we are in like we think of ourselves as kind of this like hugely interconnected world where you can like search for any bit of information at any moment, you can connect with any person you want. A lot of information is still really siloed, and I think one of the barriers is like this idea of almost like there's like jargon barriers, or simply just there's like this, like there's a huge amount of knowledge. And so one of the things I think about with this, and this is not quite going to like some of the social media stuff, but the idea is like when you have a huge number of like non-overlapping scientific fields, you end up, even though you think, okay, like information is going to be shared very equally, very, very widely, you still get the rediscovery of scientific ideas over and over in different fields, like sometimes like years or decades later, where like might be like a different field might rediscover something that has been well known in some other field because they weren't talking to each other. And so there's actually there was a paper and similar to this, there's also this idea that because fields are not able to talk to each other, there's just a lot of potential new knowledge that's just like lying on the table. So like there's this idea of it was developed in the mid 1980s by this information scientist Don Swanson, known as undiscovered public knowledge. This idea that he like spins this like thought experiment, saying, okay, imagine somewhere in the scientific literature there's a paper that says A implies B, and then somewhere else in the scientific literature, maybe in the same subfield, maybe somewhere else, there's another paper that says B implies C. But because of the vast scientific literature, no person has actually read all the papers that are out there and realize that maybe we should connect these two papers. And maybe, in fact, because of these two papers, A implies C. And so there's this undiscovered knowledge that's out there. And the cool thing is that actually Swanson was not just content leaving this as a thought experiment. He then used sort of the cutting edge technology at the time, which I think was like using like search terms on like a Medline database. But he actually found, I believe, like a relationship between consuming fish oil and like helping treat some sort of like circulatory disorder. And then I think he ended up even publishing it within a medical journal, even though he didn't really have medical expertise. And he showed that there's just a huge amount of knowledge that's out there and like things that could be learned even more, but we're not, because our social networks are such that they're often like more balkanized in many ways than we might think. And so in the same way you were talking about like the error can persist for a long time, we're also just missing lots of information where people are rediscovering or reinventing new ideas in one domain after another because they're not talking to each other. There's information that we have not learned and new knowledge we haven't learned because various fields are not talking to each other. And so I think one of the really important things, at least from like a scientific perspective, is having people who who can interact across different domains, sort of like more interdisciplinary thinking, which a lot of people talk about. But so there's this concept of what people refer to as the T-shaped individual. The idea of you have like the vertical part of a T, sort of like your depth of knowledge within a certain domain, and then you have the horizontal part of the T, sort of your ability to interact across different domains. And I think more and more we need lots of people like that, because otherwise, not only are we going to have just errors persisting in areas and like kind of fake news, without people being able to say from like a domain maybe like one step over, saying, guess what, like that actually has like been overturned and it's been wrong for a while, or we actually knew about this for quite some time. But we can also then learn things a lot better and actually create new knowledge by just connecting different domains together.
Just as kind of an aside, what do you make of the, quote, replication crisis that's out? The idea being that there are certain studies that are put out, they might capture a ton of media attention as a result of their findings, but they're never replicated, which is an important part of the scientific process to ensure that the original finding wasn't just some sort of fluke.
It's definitely a problem. It's certainly a concern. And the one thing actually,
do you think it's a crisis though?
Crisis is a little, and maybe it's a little strong, but I do think so in my book, when I wrote about this, one of the things I was concerned about is that I mentioned that the reason it's such a problem is because people are not, they don't gain prestige in the same way just by replicating someone else's work as they do by like doing something new. Mm-hmm. And I thought because of that, there's going to continue being this sort of problem. And the one thing I've actually been gratified to see since the publication of my book, not related to me, but like the fact that to a certain degree, I was wrong about this. There are actually now projects trying to replicate lots and lots of research, and in many cases showing that a lot of these things are not replicable. So I think it's not as much of a crisis. It's the fact that like we need better mechanisms for like incentivizing and rewarding people who actually try to replicate science and make sure it is this replicable, repeatable body of knowledge. Because otherwise, there will be, if people only are trying to do new things as opposed to actually trying to make sure that what has been published is correct, we're going to end up with, we're going to end up with a lot of spurious results. And so the one thing I have seen over the past few years is that because of a heightened awareness and people talking about this kind of problem, we are now creating new projects and new ways of trying to make things more replicable, whether or not it's making it easier to kind of share the underlying computational model for when you do your analysis, or allowing people to kind of be rewarded when they try to actually try to replicate things and things are not replicable. So it's certainly a crisis. I guess crisis is not too alarmist. I would say it's certainly a problem. The one nice thing, I would say the one like sliver of hope is that it seems as if because of the heightened awareness of this, we are now having mechanisms to incentivize people to actually try to make sure that science is replicable as possible. And so hopefully in the future, we won't have as many of these problems.
I want to close up by asking you how much of the knowledge in your book or the studies that you cite have reached their half-life or have become irrelevant or have been overturned. Your book came out in 2012. We're going on 6 years since its publication. What else have you learned and what have you found to be wrong in your original work?
Sure. And well, certainly, the one thing what I said where I thought like the replication crisis, like people would not be would have no incentives for replicating things. I turned out to be wrong. And I feel very glad that I was wrong because that means science is doing the right thing. One other thing, I certainly don't know a percentage of which things have been kind of overturned, but I can definitely tell a story. So actually it turns out, so one of the stories in the hardcover edition of my book is about the an error, kind of like a typographical error related to the iron content of spinach and how it kind of persisted for decades. And it turns out between the time my book went to press and when it was actually published, I learned that actually this story was not actually fully true. So it turned out, so what happened was, and so when I wrote this story, I quoted this, I quoted the story within a British medical journal that was, I think the article was from 1980 or so about this kind of typo that kind of led people to think that iron had, or that spinach had 10 times more iron than it actually did. And because of that, we have Popeye and all these kinds of things. And it turns out this is probably not correct. It was probably, there was maybe some experimental contamination issues or confusion between iron oxide and iron. But this error in the late 19th century or whenever it was actually corrected relatively quickly. I think in the span of a couple decades or so. I think like the earliest 20th century is not, as opposed to like all the way into like the 1930s. And it's true, but this story, the story of how error persists, the story itself, this erroneous story, was only debunked, I think, in like 2010. And I actually was not made aware of it until like mid 2012, whenever my book had gone to press. And so so then I was able to kind of mention that, and then kind of also include that in sort of like an afterword, like the whole story of the story and the afterword of my paperback edition. So that was kind of exciting. Another thing, and this was not necessarily from the book, but I remember one of an essay that I wrote that related to some of the idea, like kind of an essay that I wrote related to some of the ideas of the book before I published it. I use this kind of like well-worn like analogy of like people always talking about like when things change slowly, it's sort of like a frog being boiled in water. And like if you kind of like a frog will jump out of boiling water, but if you slowly raise the temperature, the frog will be used to it and then will just be kind of boiled alive. And it turns out this is not true. And James Fallows, a writer at The Atlantic, he actually has devoted a lot of effort to kind of like root out this error. And it turns out, I think people have actually tried this, and it's like only true if the frog is brain dead or something like that, which reduces the effectiveness of the story quite a bit.
Yeah.
And so I was able to actually include that within the book, by kind of saying like that actually, like, guess what, this story is not actually accurate. But I'm sure, yeah, there are many things as well.
All right. Well, I think we're going to leave it there. We've been talking for close to an hour now. Sam, I really appreciate you coming on the show.
It's my pleasure. Thanks so much.
That was Samuel Arbesman, and his book is The Half-Life of Facts: Why Everything We Know Has an Expiration Date. You can learn more about Samuel and his work by visiting his website, arbesman.net. That is ARBESMAN.net. This podcast is hosted and produced and recorded by me, Nico Perino, and edited by Aaron Reese. To learn more about So to Speak, you can follow us on Twitter at twitter.com/freespeechtalk, or like us on Facebook at facebook.com/so-to-speak-podcast. You can also email us feedback at sotospeak@thefire.org. And if you enjoyed this episode, please consider leaving us a review on iTunes or wherever else you get your podcasts. Reviews help us attract new listeners to this show. And until next time, thanks for listening and happy holidays. We'll be back again in 2 weeks.